In this video, I'm going to give the answers to the 1.1 homework out of the book, and in some cases, I'm going to explain further some of those answers. So let's get started. So we started out on page 8 with 13 to 21 odd. So in 13, the lines that are only in plane Q, the ones that are labeled are line N and line Q, lowercase q. However, if you also decided to name some other lines that weren't labeled, there were some other examples such as line GP, line GH, GL, and then you could also include PH and PL, or instead of line Q, you could have also called it line HL. So as long as you had at least several of those, so at a bare minimum N and Q, and then any others, you got that correct. On number 15, the plane that contains both lines M and T is plane R, so that is a capital R. However, if you picked any 3 points out of the ones labeled on plane R, so any 3 of A, B, C, E, or F, and you called it plane point 1, point 2, point 3, then that is also a correct answer. For number 17, again, there's more than one right answer. So you're looking for any point that is not on plane R. So in this case, the possible answers are D, or M, or G, P, H, or L. So as long as you picked one of those 6 answer choices, you got that correct. On number 19, the points that are not contained in a line that are shown, the only one that is there in the top plane is point A, and in the bottom plane, point P is also not in a line that is shown. At number 21, the question is, does line N intersect with line Q? And while they don't intersect on the diagram, the answer is yes, just not where it's shown. As long as you put yes and you had an explanation that was something along those lines, then you had that correct. For numbers 23 through 31 odd, we were looking at various shapes or descriptions of shapes or items and trying to use the geometric term that describe them. So we are in a unit on points, lines, or planes, so most of those we want to use those first, but there are some other ones that we could possibly use as well, and I'll cover those as we go through. So on 23, this was a part of the roof of, it looks like a doghouse or a small house possibly. And so it's a flat surface, so the best answer is a plane. However, if you're looking at the edges, which were highlighted, you could also call these intersecting lines. And although it's not a geometric term from this unit, you could actually call that a rectangle as well. On 25, it was 2 intersecting planes. But again, you could also call it intersecting lines. You could call it intersecting rectangles. On 27, a knot in a rope is best described as a point. In 29, the edge of a desk is most likely described as a line. However, some of you guys decided to call it a plane because it does actually have more than one dimension, so that was okay. And then on 31, a partially open folder, the best description is intersecting planes. But if you called it 2 rectangles, that would not be incorrect. Just remember we're in the unit on points, lines, or planes, so if you could connect it to one of those 3 terms, that's the best thing for right now. On 33, through 39, you were looking to draw and label a figure for each of these descriptions. So number 33 is two planes that do not intersect. Now, I'm never going to grade you on your artistic abilities because mine aren't that hot either. But if I have two planes that don't intersect, we saw a couple of these examples in the textbook. So drawing two shapes like that, if you wanted to make it clear that those don't intersect, you could draw a line coming through here and you could kind of dash it. And then you could make it go through here and then come out the bottom. And then it would be very clear that those two planes are not intersecting. On number 35, for three lines that all intersect at point J, but do not lie in the same plane. So here, it's probably going to be easiest if you show a plane, and then you have two lines that are very clearly in that plane, and then one that extends above and below, and then you do need to label that middle point as point J. On number 37, lines LM and NP are coplanar but do not intersect. So in that case, again, if they're going to be coplanar, it's easiest to depict them if they are on a plane. And then I would draw two parallel lines to the best of my artistic ability. And then because it does give you the name of those lines and points, you want to make sure that you label them. So L and M are on one line, and then N and P. If your artistic abilities are like mine, you might want to say lines are parallel. On number 39, we are looking at two lines that intersect, S and T, and then a third line, line V, that does not intersect with either of those. So if I was just working with a single piece of paper, I would have to have all three lines intersect at some point. But because in geometry now we have 3 dimensions, I can have line S and line T, and then in another plane up here, I can have line V, and so those do not intersect. You could draw S and T in any direction and line V in any direction, so long as S and T both intersect, and it doesn't matter which plane is on top and which one's on bottom. Similarly, in 37, your lines could go a different direction. In 35, your lines could have gone in a different direction. Here, these are just example sketches of what your answer could have looked like. Number 41 asked on a dish packing box, which part of the box would model lines? Here, the most appropriate answer is the edges of the box. But if you were looking at it from a vertical perspective, if you also put the dividers, then that one would be okay. Although edges is definitely the most appropriate answer to this question. Number 43 had a different figure and asked you to name two collinear points. By definition, any 2 points are collinear because you can draw a line between them. So as long as you named 2 points that were on that figure, you had a correct answer. The only thing that was not a point was plane A on the bottom of the figure was labeled. So I'm going to say any 2 letters except A. So those are any of the letters shown. In number 45, it asks, does plane A and plane MNP intersect? So, in this case, the answer is no, and you can see that because none of their lines that they have on there are in common. So, whatever way you describe that picture, as long as it answers the question, is fine. On 47, it asks, are the points T, S, R, Q, and V coplanar? So in this case, the answer is no, because V is not on the same plane as the others. Number 49 dealt with the street sign question. So in this case, the names of the streets were on a finite plane, so a plane that has an edge, and then the pole would be modeled as a line. So in this case, A asked what the intersection between the signs and the pole could be described as. Now in this case, because it says the signs and the pole, so if I was going to look at this from the top, I'd have one sign that goes like this, another sign that goes like this, and then going into the page, there's the pole. And so that's a three-dimensional pole going in, although we're calling it a line, so it's only kind of two. So the best answer to this one is a line. However, if you interpreted that as just the point where the one sign meets the other sign in addition to the pole, which is kind of what B was asking, although it was very unclear the difference. So that one was a point. So if you put point for A as well as for B, that's not completely incorrect. So that is another correct answer depending on how you interpreted that. Number 50 was the problem with the 1 point perspective, the inside of a room, talking about vanishing points. So in this case, what you want to do is the ceiling is the blue area in that drawing, the floor is the pinkish red, and the walls are colored in yellow. So the point where all the lines that represent a horizontal line in the picture, so in this case, the edge of the ceiling with the wall is actually a horizontal line. And then where the floor meets the wall is also a horizontal line. So all four of those blue lines, if you extended them, they meet at point E. So the answer to A, where is the vanishing point? The answer to that is point E, because that's where all those horizontal lines meet. Now, on B, it asks you to trace the figure, so essentially you would create something similar to what I've made, and then you're going to draw lines from the vanishing point through each of the 8 points between A and B. And I'm not going to do all of them, but you go from E, and then so A is here, and B is over here, and so you draw various lines that go out in a fan shape like that. So part C asks you, how could you change the drawing to make the back wall of the room appear farther away? And so in this case, to make the back of the room look farther away, you would want the back wall to look smaller, so you would want A and B to be closer. So you would draw something that looks like this. And again, I will never grade you on artistic ability, but that's what it's looking for. Number 51 was a 2-point vanishing point drawing. So A would just ask you to trace the drawing of the castle, including at least 5 of the vertical lines used. So this is my sketch. Again, I'm not grading on artistic ability. And so the vertical lines are the ones that are vertical in this drawing, and if you can imagine this in your head as a real-life structure. On B, you're going to take anything that would be a horizontal line on the actual structure, so something like where the building meets the ground, and you're going to extend that out. And then you'll take on the same side of the building, you'll take the little parapet, and you'll take the top of the taller tower, and they're all going to end up meeting, and if I had drawn this entirely correctly, they all end up meeting at the same point, and that's a vanishing point. Because my sketch is entirely freehand, it doesn't work out perfectly, but you can kind of see the idea. On the other side, you would take them all, and you would do the same thing, and you'd extend them out. And again, they're all going to end up meeting somewhere off the actual sketch, but you can imagine that if those lines extended, that's where they would all disappear to. So on part C, it asks you, what do you notice about the vertical lines as they get closer to the vanishing point? So if I compare this line and this line, my building's not any shorter as it gets farther away from me, but those lines get smaller. And for D, you would draw a 2-point perspective of a home or a room in a home, And in this one, there's going to be lots of various correct answers. On number 52, you had to name 2 points that are on the same line in the figure, and then you had to support your claim. So obviously, point A was going to be one of your choices because it was on the left side of the diagram. And then there were several possibilities. There were options B, C, or D on the right-hand side. If you just looked at it, you could say B because it looks like it's on the same line. Because it looks like it. Or maybe you got out something that had a straight edge like a ruler and you discovered that actually C, and that's because you actually used a straight edge to figure out which line continued through. On number 53, this one was looking at 2 cars in an intersection, and if you have 2 cars, there's a possibility for them to collide if they don't alter course or speed. However, 2 airplanes could cross paths in traveling in different directions without colliding. And so the way that that is possible is by adding the vertical dimension. So 2 cars, if they're driving on the road, obviously they're both on the ground. However, I could have one airplane at a low altitude and another one crossing directly above it at a higher altitude, and so since they're at different heights, they're not going to collide. Number 54 talked about a locus, which is a group of points that is a solution to a particular condition. So in this case, we were looking at a table, a graph, and then a verbal description of the equation 2 plus x equals y. So part A asks you for a table. So you're going to look at your table with x and y, and you're just going to pick any 5, because it asks for at least 5, any 5 values of x, and then just solve for y. So in this case, you could pick 0, 1, 2, 3, and 4. And that will give you 5 different points in your table. So if x is 0, I add 2, and y is 2. When x is 1, y is 3, and you can kind of start seeing the pattern here of how that works. In B, you had to graph this. So if I rearrange this equation, and I just write it as y equals x plus 2, I now have something that is in slope-intercept form. So when x equals 0, y equals 2, so my intercept is going to happen at y equals 2, and then my slope is 1, so for every 1 I go over, I go up 1, and now I have 2 points that I connect to make a line. So if I was going to describe this verbally, as in part C, I would say it's a straight line with an intercept at y equals 2 and a slope of 1. You don't have to have your description match word for word, but something along those lines. On number 53, we were talking about the probability that out of the line that contains F, G, and H, and then a point out here, K, that if you randomly chose 3 out of those 4, what was the probability that those 3 would be collinear, and if they would be coplanar? Now, on pulling 3 of them out of the hat, the options are all but F, all but G, all but H, or all but K. So you could have F, G, H, F, G, K. You could have F, H, K, or you could have G, H, K. Because it doesn't matter what order you pull them out, right? But those are the only 4 options. So we know our probability is going to be out of 4 for each of those. Now in A, it's going to ask which probability they are collinear. So the only 3 of those points that are collinear are F, G, and H, which means the only option out of these that are collinear is F, G, and H. There's only one option out of 4, so our probability is 1/4. For B, by definition, all right, any 4 points, all right, like in this setup, are going to be coplanar because these are all in a line, so they are all in a plane no matter what else I do. And then K, so for example, on my iPad screen, these are all coplanar. So it doesn't matter which 3 I pick, all 4 possibilities give me a coplanar combination, and 4 out of 4 equals 1. Number 56 is very similar to 54, so except now we're going to look at an inequality. And the inequality we're going to look at is y is less than negative 3x minus 1. Again, we're going to look at a table, and I'm only going to do 5 examples here. I might do a few more. And so I'm going to, again, pick some easy values of x, but because it's an inequality, I can double up on them, and that's okay. And I'm only going to do 8 for you. So if x equals 0, then this part is 0, and then minus 1 is negative 1. So y has to be less than that. So I can do negative 2, negative 3. If x is 1, then that's negative 3x minus 1 equals negative 4. I need a number less than that. So negative 5, negative 6. So you can kind of see how this is going to start working. And so you would just start going through and figuring it out. If x is 2, then I'm going to have negative 6 minus 1 is negative 7, so negative 8, negative 9, and then here, negative 11, negative 12. These are by no means the only possible answers to put in your table. They're just kind of some of the easier ones to come up with. So, part B also asks you to graph. So, remember with inequalities, you treat it like it was a line. So I'm going to start out by graphing y equals negative 3x minus 1. So in this case, my intercept is negative 1. So when x equals 0, y goes through here. And then my slope is negative 3. So for every rise, it's rise over run. So I'm going to go actually down a negative 3 for every 1 I run. So then I'm going to connect those lines, or connect those dots. And now I have a line, but because it's an inequality, so my line is not in my solution. So what I'm going to do is I'm going to make this a dashed line. And so now I'm going to shade in everything below that line because it is less than. So everything down here is part of my solution set. So when I write this in words, I'm going to say the area below, but not including the line y equals negative 3x minus 1. You could describe that again in a similar way. Instead of using the equation for the line, you could describe it like we did in 54. I'm doing it here for brevity. Almost done. So we're going to look just now at 60 through 67. On number 60, the answer to this one is no. The question asks you, is it possible for 2 points on the surface of a prism to be neither collinear nor coplanar? By definition, you can draw a line through any 2 points, and if they're on the same line, then they must also be on the same plane. It may not be the surface of the prism that defines that line or that plane, but any 2 points are collinear and any 2 points are coplanar. Number 61 is extremely open-ended. Basically anything in real life that is a plane, whether it's a TV screen, whether it's a piece of paper, whether it's a desktop, whatever it is, as long as it's a flat surface that has edges, that's a finite plane. To wrap up here, we finished with some multiple choice questions. On 62, the answer was A. On 63, it wasn't multiple choice. We just kind of had to play with 4 different lines, and because they were all coplanar, you could draw them out on a piece of paper, and the answer here is 6. On 64, it was all that apply, so the answers were B, C, or D, and the definition there of an undefined term is on the first page of your notes packet. For 65, the correct answer is B. Although we did not cover that term in particular, you can get to that one through process of elimination. Because they are perpendicular, the sidewalk is horizontal and the flagpole is vertical. They're not collinear, they're not parallel, and because the flagpole is not on the sidewalk, they are not intersecting. For our final 2 answers, the answer to 66 is D, the circle drawn by the pencil, and on 67, the correct answer is C, a plane.